What is electrolytic cell? Electrolytic cell is a device which converts electrical energy into chemical energy. The very important is whatever you take any types of electrolytes, any number of electrolytes, but the amount of electricity which is passing through different electrolyte solution must be same. When I electrolyze concentrated sulfuric acid, S2OA2- ion is formed. Hello my dear students, I am Vidhyaashram, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. My dear students, today I am going to deal with the fourth session of chapter Electrochemistry. Fourth session of chapter Electrochemistry. In the previous session, that is in the third session, I discussed about factors affecting conductivity and molar conductivity, Kohlrausch law, as well as application of Kohlrausch law. So, how the dilution affects conductivity and molar conductivity, Kohlrausch law. From Kohlrausch law, how we are going to find out limiting molar conductivity of weak electrolyte, as well as what are the application of Kohlrausch law, I discussed in the third session. In this session, that is in the fourth session, I am going to discuss about electrolytic cell and electrolysis, quantitative aspects of electrolysis, Faraday's first law and Faraday's second law, and some of the problems related with Faraday's first law and Faraday's second law. So, my dear student, today's session deal with electrolytic cell and electrolysis and its quantitative aspects of electrolysis, Faraday's first law of electrolysis and Faraday's second law of electrolysis. My dear student, already in the introduction had given explanation about cell, and I explained that there are two types of cell, electrochemical cell and electrolytic cell. Electrochemical cell and electrolytic cell. A cell which is used to convert chemical energy into electrical energy, that is called as electrochemical cell. That is called as what? Electrochemical cell. Therefore, my dear student, what is electrochemical cell? Electrochemical cell is a cell which converts chemical energy into electrical energy. Today I am going to deal with electrolytic cells and electrolysis. What is electrolytic cell? Which converts electrical energy into chemical energy. When electrical energy is converted into chemical energy, the device uses electrolytic cell. Therefore, we have two types of cell, electrochemical cell and electrolytic cell. What is electrochemical cell? Electrochemical cell is a device which converts chemical energy into electrical energy. What is electrolytic cell? Electrolytic cell is a device which converts electrical energy into chemical energy. Therefore, so what is electrolytic cell? A cell in which electrical energy is converted into chemical energy is called as what? Electrolytic cell. Therefore, today's topic is electrolytic cell and electrolysis. Regarding with electrolysis, we have two laws, Faraday's first law as well as Faraday's second law. Then, what is electrolysis? For example, when you take electrolyte, so already I told you that what are electrolytes? Electrolytes are the substances which conduct electricity in their aqueous state or in their molten state. Through electrolyte, when you pass electric current through electrolyte, they decompose into simpler substances. The electrolyte decomposes into simpler substances by passing electric current. That phenomenon, that process is called as what? Electrolysis. That is called as what? Electrolysis. Therefore, what is electrolysis? Electrolysis means decomposition of an electrolyte into simpler substances by passing electric current. By passing electric current is called as electrolysis. What is electrolytic cell? Once again, I am repeating, my dear student. What is electrolytic cell? Electrolytic cell is a cell which convert electrical energy into chemical energy. Second terminology, what is electrolysis? Electrolysis means decomposition of an electrolyte. Into simpler substances by passing electric current is called as what? Electrolysis. So, this is the diagram of electrolysis. When you take an electrolyte, it decomposes into simpler substances by passing electric current is called as what? Electrolysis. Regarding with this electrolysis, we have two laws. Faraday's first law of electrolysis and Faraday's second law of electrolysis. Let us consider first the Faraday's first law of electrolysis. Okay. When you pass electric current through an electrolyte, so we need a cell. Cell means there is an arrangement of two electrodes. One is anode, other one is a cathode. Anode and cathode. Two electrodes are there in a cell, anode and cathode. When you pass electric current through an electrolytic solution, a mass which get liberated, either some mass is get liberated or which get deposited or it get dissolved What are the three possibilities which takes place at electrodes? At electrodes, what are the three possibilities? Either deposition, either dissolution, either liberation. The mass of a substance which get liberated, which get deposited, which get dissolved at the electrodes is directly proportional to the quantity of electric current which pass through the electrolytic solution. Whatever the amount of substance which get deposited, which get dissolved, which get liberated at electrodes is directly proportional to the quantity of electric current which passing through the electrolytic solution. Totally, mass is directly proportional to the quantity of electric current which pass through the electrolytic solution. That means, as you increase the amount of electric current which passing through the electrolytic solution, the amount of mass which is get deposited, liberated as well as dissolved is also increases. That is, mass is directly proportional to Q. Mass is directly proportional to Q. That is, W is directly proportional to Q. W is the mass of the substance deposited by passing Q coulombs of charge. W is directly proportional to Q. Q is in coulomb, I is in ampere, T is in second. What is Q coulomb of charge? Q coulomb of charge means by passing 1 ampere of current in 1 second. In 1 second. Okay. Q is in coulombs, I is in ampere, T is in second. A coulomb is the quantity of charge when a current of 1 ampere is passed for 1 second. What is a coulomb? Coulomb is a quantity of charge. When a current of 1 ampere is passed through in 1 second. Therefore, you can write Q is equal to IT. What is Q? Q is the charge in coulombs. So, I is current in amperes, T is time in second. Therefore, Q is equal to IT. If you substitute Q is equal to IT here, that is W is directly proportional to IT. If you remove the proportionality sign, W is equal to ZIT. This is the mathematical form of Faraday's first law of electrolysis. Faraday's first law of what? Electrolysis. Okay. W is equal to ZIT. What is Q? Q is a charge in coulomb. Okay, once again I'll repeat, Faraday's first law of electrolysis. Faraday's first law of electrolysis. What's the statement of Faraday's first law of electrolysis? The amount of substance which get dissolved, which get liberated or which get deposited at electrodes is directly proportional to the quantity of electric current which pass through the electrolytic solution. That is, W is directly proportional to Q. What is W? W is the mass of the substance deposited. Q is the coulombs of charge. What is coulombs of charge? It is the amount of charge. That is, coulomb is the quantity of the charge. What is coulomb? Coulomb is the quantity of charge when a current of 1 ampere is passed in 1 second. That is, instead of Q, you can substitute IT. Q is equal to IT. What is I? Current in amperes. What is time? Time in second. That is, Q is equal to IT. When you substitute in place of W is directly proportional to Q, in place of Q you substitute IT. When you remove the proportionality sign, you put constant Z. Therefore, W is equal to Z IT. It is the mathematical form of Faraday's first law of electrolysis. Faraday's first law of what? Electrolysis. Okay. Now, W is equal to Z into I into T. Okay. You take current as 1 ampere. Current as 1 ampere. Time in, time is 1 second. Then W is equal to Z. What is Z? Z is constant. It is called as electrochemical equivalent. It is called as what? Electrochemical equivalent. It is called as what? Electrochemical equivalent. So, what is Z? Z is the electrochemical equivalent. Therefore, what is electrochemical equivalent? Electrochemical equivalent is the amount of substance which get deposited by passing 1 ampere of current in 1 second. In 1 second. When I is 1 ampere and time is in 1 second, W will become Z. What is Z? Z is electrochemical equivalent. So, electrochemical equivalent is the amount of substance which get deposited by passing 1 ampere of current in 1 second or by passing 1 coulomb of charge. 1 coulomb of charge, where Z is constant, known as what? Already I told you that electrochemical equivalent, and it is characteristic of the substance deposited. When current of 1 ampere is passed for 1 second, that is 1 coulomb. Q is equal to 1, W is equal to Z. What is Z? Z is electrochemical. Z is electrochemical equivalent. Z is equal to electrochemical equivalent. What is electrochemical equivalent? Electrochemical equivalent is the mass of the substance deposited during the electrolysis of 1 coulomb of charge. During the electrolysis of 1 coulomb of charge. During the electrolysis of 1 coulomb of charge, or by passing 1 ampere of current in 1 second. In 1 second. That is example. When a charge of 1 coulomb is passed through silver nitrate solution, amount of silver deposited is 0.0011118 gram. This is the value of electrochemical equivalent of silver. The amount of electricity required for oxidation and reduction depends on the stoichiometry of the electrode reaction. For example, for silver, it requires 1 mole of electrolyte because it has valency +1. It requires 1 mole of electrolyte and it is become Ag. 1 mole of electron is required for the reduction of 1 mole of silver ion into silver. So that charge on 1 electron is equal to 1.602 into 10 to the power of -19 coulomb. Therefore, what is the charge on 1 mole of an electrolyte? Electron. Charge on 1 mole of electron. 1 mole of charge on 1 mole of electron is equal to Avogadro number into 1.602 into 10 to the power of -19. So, what is Avogadro number? 6.023 into 10 to the power of 23. Charge on 1 electron is 1.602 into 10 to the power of -19. It is equal to 96,000 487 coulomb. We'll take it as approximately 96,500 coulomb in the calculation. This quantity of electricity is called as Faraday. It is represented by symbol F. 1 Faraday is equal to 96,487 coulomb. Approximately we'll take it as 96,500. Therefore, Faraday is defined as the total charge carried by 1 mole of electrolyte. What is Faraday? Faraday is the total charge carried by 1 mole of electrolyte, electron. So 1 mole of electron which carries some charge, that charge is called as what? Faraday. 1 Faraday is equal to 96,487 coulomb, which is approximately taken as 96,500 coulomb. Therefore, so how much of Faraday? It will depends upon the stoichiometry of the electrode reaction. Stoichiometry of the electrode reaction. For example, if you take a copper ions are get reduced to copper, means you require 2 moles of electron. Therefore, you require 2 Faraday. You require 2 Faraday. When you consider aluminium, what's the valency of aluminium ion? Al3+. Therefore, it requires 3 Faraday of what? Electric charge. So, therefore, it depends upon the stoichiometry of the electrode reaction. Stoichiometry of the electrode reaction. Okay. Next up, Faraday's second law of electrolysis. Okay. Faraday's second law of electrolysis. Now, I'll take different electrolytes. Electrolyte 1, electrolyte 2. 1, electrolyte 1, electrolyte 2, electrolyte 3. To this, I am going to pass same quantity of or same amount of electricity. I am going to pass same amount of electricity through electrolytes, electrolyte 1, electrolyte 2, electrolyte 3. When I am going to pass same amount of electricity through different electrolytic solution, the amount of substance which get deposited, dissolved or liberated is directly proportional to chemical equivalent mass. Here, the very important is whatever you take any types of electrolytes, any number of electrolytes, but the amount of electricity which is passing through different electrolyte solution must be same. So, when you pass same amount of electricity through different electrolyte solution, the amount of substance which get deposited, which get liberated, which get dissolved is directly proportional to chemical equivalent mass, that is W is directly proportional to E. Faraday's first law of electrolysis, W is directly proportional to Q. In the second law, W is directly proportional to E. What is E? E is chemical equivalent mass. What is E? Chemical equivalent mass. Once again, I'll write the masses of the different substances liberated, deposited or dissolved by passing same amount of electricity through different electrolyte solution are directly proportional to their respective chemical equivalent masses. W is directly proportional to E. W is directly proportional to E. For example, when the same current is passed through a solution of sulfuric acid and copper sulfate for the period of time, then W1 is directly proportional to E1 and W2 is directly proportional to E2. E1 is sulfuric acid, this is copper sulfate, it is copper sulfate. Therefore, W1 divided by W2 is equal to E1 divided by E2. That is, W1 is the mass of copper deposited, W2 is the mass of hydrogen gas liberated, E1 is the equivalent mass of copper, E2 is the equivalent mass of hydrogen. Therefore, the mathematical form of Faraday's second law of electrolysis is W1 by W2 is equal to E1 divided by E2. W1 divided by W2 is equal to E1 divided by E2. Okay. W1 divided by W2 is equal to E1 divided by E2. Okay. Therefore, was the statement of Faraday's second law of electrolysis? Faraday's second law of electrolysis states that when same amount of electricity is passing through different electrolyte solution, the amount of substance which get liberated, which get dissolved or which get deposited is directly proportional to chemical equivalent mass. Chemical equivalent mass, that is W is directly proportional to E. When you take on two substances, the mathematical form of Faraday's second law of electrolysis is W1 divided by E1 is equal to W2 divided by E2. W2 divided by E2. Now, this electrolysis, what is electrolysis? Already I explained. The decomposition of an electrolyte into simpler substances by passing electric current is known as electrolysis. This electrolysis depends upon certain factors. They depends upon what? Certain factor. The product of electrolysis are determined by 4 factors. First one, the very important, the nature of electrolyte and type of electrode, standard electrode potential of competing ions, concentration of the solution of electrolyte, and over potential or over voltage. The products of electrolysis, during electrolysis, products are formed. This product of electrolysis depends upon how many factors? 4 factors. What are the 4 factors? The nature of the electrolyte and the type of the electrode, standard electrode potentials of the competing ions, concentration of the solution of the electrolyte, over potential or over voltage. Over potential or over voltage. First one, let us consider nature of electrolyte and type of the electrodes. The products of the electrolysis depends upon nature of the electrolyte and electrodes. In electrode, we have 2 electrodes, inert electrodes and active electrodes. Inert electrodes as well as what? Active electrode. Inert electrodes, very beautiful example, platinum and gold. These inert electrodes, they does not participate in the chemical reaction. They only a source of electron or sink for electron. It is only act as source of. What are inert electrons? Inert electrodes are those which does not participate in the chemical reaction. It is only source or sink for electron. Very beautiful example for inert electrode is gold and platinum. Gold and platinum. Other hand, electrode is reactive. It participates in the electrode reaction. Therefore, the product of electricity may be different for reactive and inert electrodes. So, when you use the reactive electrode, the products are different. When you use inert electrodes, the products are different. What's the difference between reactive electrodes and inert electrode? Reactive electrodes are involved in a chemical reaction, but inert electrode does not participate in a chemical reaction. Only it is a source or sink for electrons. So, very beautiful example for inert electrode is gold and platinum electrode. Gold and platinum. Therefore, in the electrolysis, if you use reactive electrode, you will get different product. If you use inert electrode, you will get different product. Therefore, the product of electrolysis depends upon which type of electrodes we are going to use in electrolysis. Whether you are going to use a reactive electrode or we are going to use what? Inert electrode. Inert electrode. Second point, standard electrode potentials of competing ions. Now, during the electrolysis, there is a formation of cation and anion. Some of the electrolysis, there is a formation of more than one cation and more than one anion. That is, there is a formation of 2 or 3 cations and 2 or 3 anions. For example, when there is a formation of 2 cations or 2 anions, when many cations, that is when many cations are formed during electrolysis by passing electric current, the cation whose standard, cation which has highest standard electrode potential, cation having highest standard electrode potential, cation having highest standard electrode potential, reduce first in preference to other cations. Here I am giving example. So, an aqueous solution of sodium chloride, I am taking sodium chloride. There are 2 formation of 2 cations, Na plus and H plus. What are the 2 cations formed when you are electrolysis aqueous sodium chloride? When aqueous sodium chloride is electrolytes, there is a formation of two cation. One is Na plus, another one is H plus. Okay, so there are on passing electric current, H plus is reduced first. Out of Na plus and H plus, which one is reduced first? H plus. Why? H plus has potential of 0 voltage, Na plus has potential of minus 2.71, which has highest electrode potential? Hydrogen. Therefore, standard hydrogen potential of hydrogen is 0 voltage, which is more than that of sodium, that is minus 2.71. Therefore, when there is a formation during electrolysis, when there is a formation of many cations, which one is get reduced first? Which having highest standard electrode potential. In case of anion, which one get oxidized first? Which having least standard electrode potential. Least standard electrode potential. Therefore, during electrolysis, if there is a formation of many cations and many anions, which one is reduced or oxidized first? Where cation having highest electrode, cation having highest standard electrode potential is reduced first in preference to the other cation. Many anions are present on passing electric current. Anion that has least standard electrode potential oxidized first in preference to other anions. Next, concentration of the solution of the electrolyte. For example, the concentration also depends whether we are going to take concentrated solution or dilute solution. Further, the products of electrolysis depend upon the concentration of the electrolyte. The products formed can be different when the solution of the same substance, but different concentrations are electrolyte. For example, I'll take dilute sulfuric acid, then I'll electrolyze concentrated sulfuric acid. When I am going to electrolyze dilute sulfuric acid, oxygen is evolved. Oxygen is evolved. When I electrolyze concentrated sulfuric acid, S2O8 2- ion is formed. Therefore, when you take dilute sulfuric acid and concentrated sulfuric acid, the products are different. The products are different. Therefore, the products of electrolysis, they depends upon concentration also. When you dilute sulfuric acid during electrolysis, there is evolution of O2. When you take concentrated sulfuric acid, there is a formation of ion S2O8 to the power of 2-. Okay, so this shows that the electrolysis depends upon the concentration of the solution also. Concentration of the solution also. Next, the fourth point, over potential or over voltage. What is over potential or over voltage? It is the minimum exchange potential over the standard electrode potential to require to discharge an ion. To discharge an ion, a minimum potential is required. Minimum exchange potential is required over the standard electrode potential, that is called as over potential. Liberation of gas involve over potential depending upon the type of the electrolyte. This is mainly due to polarization and adsorption of gases. Therefore, the product of electrolysis also depends upon over potential or over voltage. Over potential or what? Over voltage. Okay. Now, let us consider a problems on Faraday's first law as well as what? Second law. What current strength in ampere? We need I. How much current will be required to liberate 10 gram of chlorine from sodium chloride solution in 1 hour? Time is 1 hour, but you have to convert into second. 1 into 60 into 60 seconds. 60 into 60 seconds. Atomic mass of chlorine is 35.5. You have to find out the current strength. Already you know that Q is equal to IT. Q is equal to IT. You need I. I is equal to Q by T. I is equal to Q by T. You have to find out Q. But T is 1 hour. 1 hour I had to convert into second. So 1 into 60 into 60. I had to find out Q. Okay. So it is Na sodium chloride solution. So where chlorine is 10 gram of chlorine is liberated. So sodium chloride ionizes as Na plus and what? Cl minus. 1 mole of Cl minus, take 1 mole of, going to lose 1 mole of electrolyte to become Cl. To become Cl2, it is 2 moles as well as it is also 2. Therefore, 2 moles of electrons means it is 2 Faraday. It is 2 Faraday. 2 chlorine means 2 atoms of chlorine is 2 into 35.5. 2 into 35.5. So 2 into 96,500 coulomb is required to liberate. So 2 into 35.5 gram of chlorine, 5 gram of chlorine. Now to 10 gram of chlorine, how many coulomb of charge is required? How many coulomb Q is required? So dear student, so you had to find out I, current. So current. So we have formula Q is equal to IT. So I is equal to Q by T. I is equal to Q by T. What's the formula to calculate current? I is equal to Q by T. Okay. So consider sodium chloride. Sodium chloride ionizes as NaCl give rise to Na plus and Cl minus. 2 moles of chloride ions takes to lose 2 moles of electron to form chlorine. So 2 moles of electron means 2 Faraday. 2 chlorine atom means 2 into 35.5 Faraday. 1 Faraday is equal to 96,500 coulomb. Gives how much of chlorine is liberated? 2 into 35.5. They ask for 10 gram. For 10 gram, how much? Okay. So therefore, Q is equal to 2 into 96,500 into 10 divided by 2 into 35.5. 35.5. 2 into 96,500 into 10 divided by 2, that is divided by 35.5. 35.5. Okay. So it is 27221.4 coulomb. 27221.4 coulomb. Q. Okay. Q is equal to IT. I is equal to Q by T. I is equal to Q by T. So you have relation 2Cl minus give rise to Cl2, 2 Faraday, 2 into 35.5 gram. So 2 into 96,500 coulomb gives 2 into 35.5 gram. For 10 gram, how much required? 10 gram, how much required? When you cross multiply, Q is equal to 2 into 96,500 into 10 divided by 2 into 35.5. It is nothing but 27221.4 coulomb. So Q value is 27221.4 coulomb. Okay. Now I is equal to 27221.4. T is equal to 60 into 60. T is equal to 60 into 60. So that is 7.56 ampere. It is 7.56 ampere. So therefore, what is the current required? 7.56 ampere. This is how I did formula. I did problem by using Q is equal to IT. Q is equal to IT. Okay. Okay, you got it? So Q is equal to IT. I is equal to Q by T. Q by T. 1 Faraday is equal to 96,500 coulombs. 96,500 coulomb. Okay. Next problem. How long has a current of? How long? We have to find out T. Current of ampere, 3 ampere through a solution of silver metal of surface 0.42 gram. 42 gram. Atomic mass of silver is 108. Okay. Now, silver nitrate solution means silver nitrate ionizes as Ag plus and NO3 minus. 1 mole of Ag plus takes 1 mole of electron. It is become Ag. Atomic mass of Ag is 108 gram. That is 1 mole of electron means 1 Faraday. 1 Faraday means 96,500 coulombs 108. For it is to 0.42 gram. For 0.42 gram, how much you required? So therefore, Q is equal to 96,500 into 0.42 divided by 108. 96,500 into 0.42 divided by 108 is equal to 3 375.2 coulomb. 375.2 coulomb. Now Q is equal to IT. We have to find out T. T is equal to Q by I. What is Q? 375.2. I is 3 ampere. So 375 divided by 3, it is nothing but 125. It is nothing but 125 seconds. 125 seconds. 125 seconds. Therefore, so you remember, my dear students, 1 mole of an electron means 1 Faraday. 1 Faraday is 96,400 coulomb. 1 Faraday is required to reduce Ag to plus 2 Ag. How many mole of Ag is formed? 1 mole. It is 108. 96,500. 108 for 0.42, how much? That is Q is equal to 96,500 into 0.42 divided by 108. It is 375.2 coulomb. Q is equal to IT. T is equal to Q by I. Q is 375.2 divided by 3. That is 125 seconds. So, this is about problem I did. Okay. Next, in the next session, I'll come up with galvanic cell. Today in this session, I discussed about electrolytic cell and electrolysis and 2 laws, Faraday's first law and Faraday's second law. Next session, I'll come up with new concept, that is galvanic cells. Okay. So, my dear student, next session, I'll come up with new concept. That concept is galvanic cell. Until that, goodbye. Thank you. Have a nice day. Bye.